everyone. This is Anuj Rimal, and today we are presenting our senior capstone project, which is also an AI audio transcription system. This project was developed as part of our CSCI C486 course. Our goal was to build a system that can automatically convert spoken audio into accurate text using AI. In this presentation, we will walk through our project, the features we've implemented, and demonstrate the progress we've made. So here are the members of our team and our roles. My name is Anuj Rimal and I worked on the backend development and AI integration. Jack worked on AI features and performance optimization, including speaker diarization and GPU acceleration. Sahil worked on the front-end development and user interface, while Hoida focused on testing and documentation. Together, we collaborated to design, build, and improve the system throughout the semester. Our project is an AI powered audio transcription system that converts spoken audio into text. It supports both uploaded audio files and real time transcription, making it useful in different situations like lectures, meetings, and content creation. The main goal of this system is to save time and effort compared to manual transcription while still maintaining good accuracy. So overall, this project demonstrates how AI can be used to automate and improve everyday tasks.
Hi, this is Sahil, and on this slide, we're going to highlight the initial features we completed before our first demonstration. The first feature we implemented was audio upload, which allows users to input recorded audio files into the system. This serves as the main starting point for processing audio within the application. And after that, we developed basic transcription functionality using a speech-to-text API. This allows the system to automatically convert spoken audio into readable text. While this is a foundational feature, it is critical because it enables all other features in the system. We also created a simple user interface to display the transcription results. The focus at this stage was not on advanced design, but on making sure the interface was clean, easy to use, and functional. Users are able to view the generated transcript clearly without confusion. In addition, we completed initial testing to ensure the system was functioning properly. This included testing different audio files, verifying that uploads worked correctly, and checking that the transcription output was reasonably accurate. These initial features established the core functionality of our system and provided a strong foundation for future improvements, such as adding summarization, improving the interface, and optimizing performance.
This is Zach Ganser, and I'm going to be talking about some of the new features that we've implemented post Demo 1. The most labor and time-intensive feature that we have got up and running now is a speaker diarization. This is basically in the transcript, it'll assign a speaker to everything that's said and apply it to the transcript. That way it makes it easier. Hello, Zach Ganser here again to run you through the technical implementation of our new features. The backbone, the framework for our project is Python, utilizing PySide 6. So for our diarization, we needed some new models to support that. We're using a suite of models from. Hello, Zach Ganser back here. I'm going to run you through our live demo here. Let me get this going real fast. Okay, so you can see, if you remember from last time, there are a couple new things here. We have a search bar here to search the transcript. We also have down here. This is where once the transcript and summarization are all completed, the audio file will be back right here so we can play with it. I'll show you some cool stuff with it. So I want to run you through a couple of things in the settings. So for now, I'm going to turn off offloading to the GPU for summarization. I'm going to actually set everything to settings for CPU. I'll show you some of the time save we're getting between the two, the way they run. So I'm just going to run, this is a fairly short audio recording. And this is running the way it was in the previous demonstration. We're running all of the models off the CPU, and we're going to see this is going to be so this for this file. This usually takes about 2.5 minutes or so to run. Timing it now. We'll see how long this takes to run. Okay, so we've run through the transcription model. It has transcribed the audio. Now it's running through the diarization to grab all the different speakers. And then here in a second, we're going to get to the summarization. This is where the longest amount of time is taken to run. So we're just going to wait it out here for another minute or so. As you can see, running off the CPU, here we just go ahead and summarize it now. Running off the CPU is fairly slow. This isn't a very long audio file. It's about 3.5 minutes, I think. And so you can see this is we're coming up at about 2 minutes now of this running. You can see like this is a fairly short audio file. Taking this long to run, that's not very user friendly. Something that was a really key get for us was getting this GPU acceleration working for both Windows Linux, and Mac, because it really speeds up this process. I know if I'm a user and I'm using an app like this, I'm not going to want to have to wait, several minutes just for a short audio file to process through. Okay, so now we're combining everything together. This should be done here shortly. There we go. Okay, that took about 2 minutes and 40 seconds. So let's change some settings. We're going to set up the auto. I'm on, this is a Windows machine right now. I have a fairly beefy graphics card. I have a RTX 4070 Ti, so not super top of the line, but it's plenty beefy. So we're gonna have everything. We're gonna run through the GPU offload. We're gonna set to auto. We're gonna detect that my graphics card. You can see here, it's detecting to use the cutter because it sees my GPU. Okay, look, the transfer script ran in seconds. This is so much faster. You can see than the last run through running everything through the CPU. Like I said, this has been significant performance improvements. We're already through the diarization around to the chunk summaries, chunking the summaries to then send through to summarize fully. Let's see, we've been running for about 30 seconds. That's so much faster than the last run through on the CPU. And we're already approaching the end of this. So we should be coming up here. It's combining all the summary. It should be done here any second. And here we go, should be finishing any second now. There we go. Okay, that took about just under a minute and a half. So we got down from 2 minutes and 40 seconds down to a minute and a half. Let's see, that's roughly a 78% performance improvement. And there's additional tweaks we can make and will continue making to speed things up even more. But getting the GPU acceleration and utilization working just has immediately cut so much time off. Now we have this transcript, I can show you a couple of things. So this our search feature. So you'll search for Hill. You see there's 10 matches for Hill in here. It's nice. It's going to bring up every instance of it, and then as you tab through it, it'll highlight even more which one you're on to make it easy to keep a track of. Right now we have these kind of yellows. I'm not a huge fan. I think we're going to change the colors. The yellows, I think it can be a little tough to read some of the text through it. But we also have, so we can play the recording, and hopefully you can hear it through this. I think it's recording the desktop audio.
This is the Cal NEH American English Dialect Recordings Collection, tape number 1, side B.
So you can hear them talking. We can pause it, we can stop it, and also I think this is a really neat thing we have going. We can actually click on a section of this.
Up the hills of Habersham, down the valleys of Hull. I hurry down the hills of Habersham.
And you can see
an example of accent.
We can actually in real time sync up the audio with the part of the transcript that you're selecting, if there's a specific part you want to hear. You can also see, like I said, our timestamps are now minutes and seconds. I think it makes it a little cleaner to see. We can actually, when we see here's our diarization, you can see it's saying speaker A is speaking at the top here, speaker B is speaking down here at the bottom. And then it comes up in our summaries too, where it summarizes which speakers have brought up which points. So that's a lot of the additional features we've gotten working so far since this last demonstration. And of course, there's more we're working on, continuing to make UI improvements, continuing to try to speed up those run times. And there's some additional features, we've got kind of working on down the pipeline as well.
Hi, this is Sahil, and looking ahead, there are several areas where our project can continue to improve. One major future enhancement is adding multi-language support. This would make the system more accessible in a wider range of users. This would allow people from different backgrounds to use the application more effectively. Another important improvement is enhancing speaker recognition. Right now, the system can process audio, but improving its ability to accurately distinguish between different speakers would make the output more reliable and useful, especially in conversations or group settings. We also plan to improve the user interface and overall user experience, making the system more intuitive, more visually appealing, and easier to navigate will help users interact with it more efficiently. Overall, this project has a strong foundation, and with continued updates and improvements, the system will become more accurate, more user-friendly, and more powerful over time.